Okay, everyone, so I'm going to make a couple videos to help some of you get through this unit test that I assigned in Khan Academy. And this, of course, is Unit 11. Excuse me. It's one of the last main units that we have to learn, okay? And let's get this done right. So, anyway, so here it is. It's called Inference for Quantitative Data. Means testing, basically. And notice this coming Thursday, we have these assignments on intervals and test statistic for slope of regression that are due. So keep that in mind as the days go on. So look how simple this one is, guys. This was like problem 1 or 2 when I tried it myself. We want a 90% confidence interval. We're told our sample size is 18. So immediately what you should understand is we're going to take 18 minus 1. We know our degrees of freedom is 17. So we want to know what that critical T-star value is. Remember, whenever we make a confidence interval, guys, we take our point estimate. I'm just going to call it PE, whatever that is. And we plus or minus T-star. That's what we're trying to find here. So for 90%, we're going to find the value that makes it a 90% interval times our standard deviation or standard error. And this together, of course, makes our overall margin of error, as we like to call it, right? Well, look how simple this is. All I have to do is go to my t-table. Now, every one of you, make sure you have a t-table. And let's see here if I have a better picture. Here we go. And I'm going to go right to the very bottom, right? Go right to the very bottom. If I want 90%, I'm looking right here at my highlighted pink column here, right? And I'm going to look up until that matches over here, degrees of freedom 17. So let's go back to this one here because I think this one will work out better. So we're going to go to degrees of freedom 17. We're going to go across until it matches our 90%, which was at the very bottom there. The answer is 1.74. So we're going to select D. It's that simple. Our T-star is 1.74. All right, let's take a look at another one here. A teacher gives students time in class to study for a test. The teacher assigns each of their 24 students to either study using a set of flashcards or they create their own flashcards. So teacher-made or student-made flashcards. They plan to construct a 2-sample T-interval comparing the test scores of the two groups. So basically, we're probably just going to like flip a coin. That's what will make it random. And we go, okay, flip a coin. Heads means you have to use a teacher-made flashcards. Tails, you have to use your own flashcards, right? And they do that for the 24 students. So randomly, we're going to divide it up into 2 groups of 12, you see? So which of the following conditions do we want? Well, we definitely want our test scores. Well, we know our test scores are going to be independent, right? Because we flipped the coin to make sure they were randomly selected for either type of flashcard. So that one's valid. The teacher assigns students to groups randomly. Again, we just discussed that as well. So randomness in a way ensures independence. But remember the independence test. If I have 24, I times by 10, is it safe to say that there's 240 or more students? I'm assuming that this is a high school at least or college maybe, right? And so I think that's a pretty safe bet. Now, A is a good answer, guys, except this is for proportions. Remember when we do NP greater than or equal to 10 and N times 1 minus P greater than or equal to 10? That's when we do proportions, which we will review again very shortly. So the only 2 really good answers in this case are B and C. All right, Let's do one more here. Now, guys, notice how this sample size is really small, 7. That's why this one will never be a Z, because our sample size is, number one, too small. But notice how it's pretty symmetric. You know, it's pretty much straight across with the extra data point right there in the middle, right? So it's very, as we say, symmetric, correct? It has symmetry. Now notice sample B is not symmetric. We would say that it's skewed right. But remember, guys, as long as this sample was done randomly, because our sample size is so large, remember by CLT, whenever it's greater than or equal to 30, sample size is greater than or equal to 30, even if it's skewed right or left, we know random selection will help us get a symmetric result in our samples. So in the long run, guys, both sample A and B are good. A is good because it's inherently symmetric. B is good is because even though it's skewed, we took a large sample size, and by CLT, we're still good to go. All right, now let's just do one more since we have the time. A sociologist studying marriage in the U.S. and Canada wanted to compare how old on average women in each country are when they first got married. So we're comparing U.S. with Canada. And notice the U.S. is a little bit younger than Canada as a mean age when they got married. The researcher wants to use these results to test. Now notice our H0, guys, is when we find their difference, we're going to assume it's 0, right? And the alternative is what we're trying to prove indirectly. Notice we're suspecting that if I take U.S. minus Canada, I'm going to get less than 0. In other words, I am, without even looking at the data, that's the key thing. You're not supposed to really look at the data ahead of time. We are predicting that U.S., for some reason, tend to marry at a little bit younger age. Okay? Because that's what the alternative is telling us. So, basically, guys, what you had to do was take your calculator, go to stat, right? It's important you practice with your calculator, of course, by the way. We're going to go over to tests. And because we're comparing two different samples, we're going to do the two-sample t-test, right? So we're going to select two-sample t-test. We're going to select stats because we're actually inputting the data. Data would be, guys, if you already have it already inputted into, let's say, list 1 and list 2 or whatever, right? But no, all we have is the basic stats on U.S. and Canada. And as you can see, I want you to do this, guys, and practice inputting it. But all I did was U.S., I inputted the mean, standard deviation, sample size. I did the same thing here for Canada, right? And here is the last key thing, or next to last key thing. Notice we suspected that U.S., mu1, was going to be less than Canada, mu2. So we have to select less than. We don't want to select not equal to or greater than. And of course, because we're two different countries, we're not going to pool the data together. And once we have it set up, here's our results. So notice our p-value here, guys, is about 4%. And that's why we're going to select, I believe answer B says p is between 1% and 5%. So based on our results, by the way, because our p-value is so small, the chance that U.S. and Canada are equal to each other is basically, according to our calculations, only 4% chance of being true. So the logic is we would reject that notion, and now we've indirectly proven that for whatever reason, U.S. citizens do tend to marry at a little bit younger age than in Canada. And this should get you a good jump start, guys. I'm going to make one more video to help you out on this unit test. I'll see you in class.